Okay, so JavaScript has nothing to do with Java, but it became a popular name for a script that Netscape was considering, right, for running code inside of the browser, right? Already there had been a lot of projects that were looking to generate dynamic content on the server, right? When a browser went out to the server for asking for content, up to that point, in the early 90s, it was just HTML documents, right? These are hand coded ASCII files, and folks were saying, well, how about the server was smart enough to say, instead of just responding with a static file, what if it ran a script written in some language? Doesn't matter, right? It could be C. Uh, if instead of responding with static text, ran a program, and the program then streamed back some text, right? So there was already some investigation on using that strategy, right? Generating dynamic content from the server. But in tandem, in parallel, right, other folks were investigating, how about we run the code not on the server, but we run it on the browser, right? And that's where the idea of JavaScript became popular. And the way this worked was that we would introduce a new script tag, right? Just like there's an H1 tag, a paragraph tag, there would be a new script tag that would allow you to embed functional programs inside of that script, right? And now, what would you put in that script? What would you do in that script? Well, we already saw that, right? What browsers do is that they parse a static HTML text file, right? And they convert it into a document object model, right? Some object in memory. So what we could do from this script is to have an API that would allow us to manipulate that DOM, right? So now the HTML could either be generated on the server, right, where the HTML was computed, but when it got to the server, right, to the client could now also manipulate that DOM. Yes, right. The HTML will be parsed by the browser. The browser would create the DOM, but then the script, these JavaScript, could do some post processing, right, and maybe do some minor cosmetic changes to the DOM, right, and so that became very, very popular, from the developer's point of view, but not so popular from the user's point of view. Folks started to push back on this, on saying, oh, what do you mean when you're running this script that is downloaded from a server that I don't know? It's downloaded and it's running on my machine, on my browser. Isn't that a security concern, right? And so the browsers quickly went to address that concern of saying, well, yes, the code is downloading from a server. It is running on your computer, but it's running inside of a walled garden, right? It doesn't have access. It's not going to have access to the operating system. It's not going to have access to your file system, right? And folks were concerned that it would hack their local system, that it would overtake their computer somehow. So browsers try to alleviate those concerns, and today it's hardly a website that doesn't use JavaScript, right? But back then it was very, very concerning in the early 90s. So anyway, so it looks something like this. You have a script tag, and inside you have a commands, right, that can be executed on the browser. Right, you have a script tag that then inside you have executables. And here's the simplest. You have an alert box where you pop up a dialog. Now, we are never going to actually write low-level JavaScript, in the raw, that is directly executed by the browser. I mean, you can. It's certainly an academic curiosity, to do that. It'll be very rare that you get to do that, but you might. Instead, we are, way up here in the TypeScript world, right? And not only is it TypeScript, but it's running inside of a Next.js framework, right? And we're running code that, the way we're writing it, it's never going to actually execute on the browser, right? The browser would not know what to do with our source code. Instead, it goes through a process called transpiling, that gets not compiled because the output is not binary, right? But it gets converted into a version of JavaScript that browsers do understand, right? Into its bare bones JavaScript that any browser could understand, right? But so this is an extension of the idea of creating a virtual machine, very much like Java tried to do. Java creates a virtual machine where you program in a particular language that is not specific to any operating system, yes, but then you rely on a Java virtual machine that can be compiled. The same code can be compiled, presumably, right? So that it's applicable or runnable in any number of operating systems. Yes. So it creates a virtual version of the machine, right? Of the underlying operating system. This is trying to do something similar. We don't code directly to something that the browser would understand. We have a higher level abstraction layer, right? That these are functions that call each other and they return snippets of HTML, right? That then get interpreted by the browser, which generates the DOM. Yes. So we're way up here, and it goes through some magic that makes it into the JavaScript that gets compiled. For our point of view, we have 10, 20, 30 files. The compiled version is just one file, right? One really, really, really huge file, right? And you can open it up, you can see the actual code, and you can try to make sense out of it, right? But most of it is gibberish, right? We don't really know what's going on, right? So somebody wrote the code that converts our high-level TypeScript into, right, just plain JavaScript that browsers can understand, okay? And they do what we expect them to do, all right? Generate that user interface. So again, a lot of what I'm going to be describing here is mostly for academic purposes, right? So that you can't say that you never knew what actual JavaScript looks like. But it's important to know what's happening behind the scenes. What's happening behind the curtains. Okay. So yeah, here's some of the more simpler ways of generating content for the user. You can alert and create an alert box. All this code you can actually run from within TypeScript. Yes, but it's considered to be bad practice, right? I mean, you can certainly do console log alert, but for instance, document.write, right? You are directly writing to the DOM, right? Document is a variable, a constant, an object that is globally available, right, within the browser that has direct access to the DOM. Okay, and you can read, you can write, you can peruse through the entire document structure, right? And one of the commands is to write, right, to generate content onto this document object model, right? And you can write just regular text or formatted HTML, right? So you could generate a header, right, a heading of size 1 by doing h1 hello world close h1, right? It would create a node in memory, right? It would append it at the end of the DOM, right? It would appear in your in your document. It's very rare that you would do this from TypeScript, from React, but it does happen, especially if you are handling low-level events like mouse clicks or mouse hovers, or or you're generating events directly from within React. Oftentimes the case is that you would use a library, maybe like fabric.js or something like that. But often, sometimes it occurs that you have to directly interact with the DOM. Very, very rare, but it might happen. So it's good that you've seen it, okay? And this would be one of the few times that you'll see it. So not only can you write to the document object, but you can also read from it, right? And the DOM is a hierarchical data structure, right, with the root at the top, right, and then a whole bunch of branches, right, that you can navigate through this tree structure, right? The each node, some of them might have unique identifiers, which you can add them using the ID attribute. You've seen that, right? And you can ask the DOM, hey, look, traverse the tree using breadth first search or whatever, looking for a node who has a particular unique identifier. who says, well, this will do a global search, right, for all the nodes in the tree that have a unique identifier hello. Once you have a reference to it, you can then manipulate the node, right? You can change the look and feel, right? You can delete it, you can copy it and duplicate it. You can change its children, you can add to its children, you can do all sorts of things, that you can manipulate a data structure, right? One of the things you can do is to change the inner text or the inner HTML of that node, right? So this would be a way of manipulating the DOM, right? And so what React does is that it hides all this low-level stuff from us, okay? Right? And instead, we have this, very clean, TypeScript world, right, where it's very virtual, right? But underneath, this is what's happening, right? It translates it to this code that directly manipulates the DOM. Now, one of the things to avoid why we wouldn't want to do this is React does a lot of optimization, right? It's very time consuming. It's very computational expensive, right, to manipulate the DOM. Okay, so what React does is that it creates a virtual version of the DOM, right? That is much more compact, right? It's as a faster read write speed to this alternate representation of the object, and only converts the actually manipulates the DOM when it's absolutely necessary, right? When changes actually have occurred, right? That it will then do a fast write, right? A dump to the DOM, right? So that it gets written to the screen. Yes, right. Somewhat what databases do, right? Databases don't try to avoid read and writing to the file, to the file system. Instead, they have a virtual cache of the database, not all of it, but a big portion of it in memory, so that you are, when you're inserting or deleting or updating, a lot of those operations are done to the to the cached version of the database, right? And only when necessary will the database actually cache all these changes, right, and then do a dump to the data to the file system. Again, to avoid the chatter of back and forth to the interacting with a very slow IO. Yeah, so similar thing here, right? The React.js maintains a virtual version of the DOM, right? Again, to minimize the actual read and write to the screen, right? Again, always trying to optimize the rendering speed, right, to what you see on the screen. Yes, because I mean that's what React.js is. It's a rendering engine, right? It's a rendering engine, but to the browser. The browser is the screen, right? And we are trying to paint stuff on the screen, and so we want to optimize that, and that's what React.js does, right? It optimizes the read write to the screen. So yeah, so the way you create these primary keys is using the ID attribute, right? Which you can then retrieve using document.getElementById hello. Once you have a reference, you can then change different things such as the style. Okay, and here's where you start noting why. Remember when we were working with the style attribute in React, right? If you remember, I said that what we assign to the style attribute is an object. Okay, and you remember when I said that those objects, the properties of those objects are camel cased. Remember that, right? And the reason they're camel cased is because here, you see this? See this style attribute? Notice that it has a property font size and it's camel cased. Yeah, because this is exactly the names for the properties, right, that we are at the high level, right, manipulating from the style attribute, right? All that object, it's actually manipulating these low-level JavaScript properties that manipulate the elements, the node elements, right, in the DOM. Okay, so there's a one-to-one relationship between the names that we use, in React and the style attribute and the low-level JavaScript objects, right, that manipulate the DOM, right? Obviously, these have the CSS equivalents, right, that are all lowercase, right, and they use the dashed, right, syntax as opposed to capitalized letters. Yes, right. So, but there is a one-to-one relationship here. So yeah, when you manipulate the style attribute, you are manipulating this style property in a node. Okay. Uh, Here's another, for instance, we played around with this, earlier in the in an earlier lecture. We were playing around with the display property. Remember that we were turning on and off, right? And using none and block and flex, right? Again, we can do that directly with the using the document object model. Okay. Also, you have, since we have a programming language, we have all sorts of new data types, right? And we've only been playing around with just, plain just, strings and numbers, but you have things such as, dates, booleans, and whatnot, right? So dates is what you would expect. You can create an instance of the date object, and then you have, all sorts of properties that you can access: month, day, year, right, and things like that. You also have, obviously, complex data types such as arrays, right? That you can write, either iterate over them or write wholesale as as an object. Here's a simple example of iterating over that data structure, right? Of scores. These presumably might be quiz scores, right? With iterating over it and computing the average of the scores, and then printing out in HTML, right, the total and breaks, right? And we are concatenating this string, and this string is going to be written to the DOM, and you would see the output on the screen, right? Now notice how generating this content, right, entails manipulating strings, right? Concatenating strings, where you have total is a string concatenated with a number, concatenated with another string. This is very error prone, right? Every time you are trying to generate a language HTML from another language, JavaScript, it's very error prone, right? It's very easy to miss a quote here, right? The wrong plus sign, yes, right? And that's why we don't use JavaScript in TypeScript. We use a TypeScript with XML, TSX, which is a mixture of two languages, right? Which try to avoid this error prone syntax, right? We are, in effect, in TypeScript, generating HTML from JavaScript, yes? And in general, when one language tries to generate another language, it's very error prone. So that's why TSX tries to blur the line between these two worlds, right? The HTML world and the JavaScript world, right? So to create a brand new syntax where it's easy to jump between TypeScript and then back to HTML, and then back to JavaScript, and then back to HTML, right? Without the plus signs, without the extra quotes, without you almost feel like it's just its own new language. Yes, and that was the intent of creating JSX and TSX, right? To blur the line between these two syntheses, right? So here's another example of creating a dynamic list, right? We write the opening UL tag, and then we are appending the line item, right, with some values of scores, and closing it, and then closing the UL. Again, very, very error prone. Easy to just forget to close that UL, right? Here's another example of instead generating dynamic tables, right? We start with a single string, opening a table, and then we concatenate rows and columns, concatenating scores, right? Closing the table, and then writing the entire string to the DOM, right? It gets parsed, right, and then added as a node to the DOM. Okay. All right. So that's all that's basically what converting some data structure into some user representation, which is basically what React does, right? That's the point of React, computing the output from some data or user input. Now, user input is implemented through several event handlers, right? Every node on the DOM, right, has optional event handlers, right, that you can associate all sorts of events on any node, right? Typically, you would associate them to things such as a button, because a button is meant to be clicked. But nothing stops you from associating an event handler to a div or paragraph, right, or line item or whatever. Anything can be clicked, anything can be dragged, anything can be typed. Okay, but more typically, you would see a button that you're clicking, and to receive or to consume an event generated by a user, you can define an on-click attribute and then a function that handles that event. Okay. Now and then you would declare some function that will be invoked when that event occurs. Okay. When we see the equivalent in TypeScript, the syntax will be slightly different. Okay. It'll for instance, the onClick will be a capitalized C, right? That's minor. But one of the bigger ones that you have to be careful of is that in the low-level JavaScript, the function calls have this parentheses when you invoke them, right? You can also have that same thing in TypeScript, but you have to be careful, right? You would not directly immediately call the function. You would typically put it inside of what's called a closure, right? That which we'll see in a minute. This would actually create an infinite loop in TypeScript, right? This would cause the state of the component to change, which would tell React.js it would have to re-render, and it would re-render. It would call the function again, right? Which would cause the event to change, which would cause the component to re-render. So it would be stuck, into this re-rendering loop. So you have to be careful. Here in low-level JavaScript is perfectly fine. This means that this call has been postponed until you actually click on the button, right? So it won't be called immediately. Whereas in TypeScript it would. So careful there. All right. So now commonly in real JavaScript, the scripts typically are loaded in the head tag, right? That's the common place to put it. That is the correct syntactic place to load a script or to define a script, right? In the head tag. Okay. You open up a script, right, and you put in your beautiful code. Now, more commonly, or the appropriate thing to do is to instead have a separate file. In a separate file, you then import that file by using source, right, and then telling what the file is, right. And this would entail two requests to the server. The first request is the HTML document, right, and when the browser downloads the HTML document, as it's parsing it, it sees that you have a source there, right, which would cause the browser to make an additional request out to the server to download that additional file, right? So two requests for this one file, okay, which is important since the browser needs to be able to have multiple threads. Typically, you'll see that the browser, when it's parsing through your HTML, will open up multiple threads, right, to the server, and they'll start downloading all these scripts, downloading images, downloading movies or CSS files, all simultaneously, right? These are, and which is important to understand that the browser can have multiple threads, right? It can handle multiple requests, multiple threads simultaneously, but JavaScript itself cannot. Right? JavaScript itself, we'll see in a minute, a little later, that JavaScript only has a single thread, right? As it's running, right, and it's computing and it's handling your events and you're typing, it's only one thread. So you have to be careful, right, that you don't block that one thread, right? If you have that one thread goes out to a server to do something, and it's stuck waiting for the server to respond, right? The whole code is blocked, waiting for the response, right? It won't handle any additional clicks, any additional events. Your application will look as if it's blocked, right? So you have to be careful. It's just a single thread. So typically we would what we would do typically in one of these asynchronous calls, we would request the browser, hey browser, I only have one thread, but you have a whole bunch of threads. Can you do this for me? And we delegate this to the browser. We say, hey browser, go do this for me, right? Because you have a whole bunch of threads, but I don't. Okay, go do this for me, and then later let me know when you're done, right? I'll go do something else, right? And then interrupt me when the response comes back from the server so that I can continue my computation. So we'll take a look at this a little later. Threading is important. Now, even though the correct syntax is to declare script here up in the head in the HTML document, more commonly, you will see that scripts are declared way at the bottom of the body. Okay, and the reason is that oftentimes these scripts are somewhat large, right? Especially if you're downloading all sorts of libraries, right? You're downloading Tailwind and you're downloading Bootstrap and you're downloading React and Fabric.js and a whole bunch of other stuff, right? You're downloading all these libraries, perhaps spread out over right multiple regional places across the world. And you're downloading all these scripts. It might take a while, right, to download. Now, if you put them at the top of the document here up in the head, right, uh, you know, the browser still hasn't gotten to the actual body to render it, okay? So it might take a second or two before, it downloads all these scripts before it can even show anything on the screen, yes? So typically for optimization, we put these scripts way at the bottom of the body, yes, so that we can the content above it can be rendered quickly, for the humans to see something, right, and they don't click away. Yes, we want to pump as much content, grab the attention of the user, right, and then behind the scenes start keep downloading all the additional resources, right? So it's a very typical optimization strategy. Right. So let's discuss a few other things about manipulating HTML dynamically. One of the things obviously that you can do now is to do computations. Yes. Things such as something as simple as some arithmetics. Yes. You can do two plus three. Right. You can calculate this now. Right. And then update content dynamically with this output. Right. You can also interact with input fields, right? Those input fields that we we're playing around early on with HTML. Well, now we can actually interact with them. We can go back and see if the user actually typed something, right? We can grab their by unique identifier, right? And then we can ask for the actual value that the user typed on the input field, right? And then we can maybe just alert, right? So a simple calculator might look something like this. You have a couple of input fields, right? And then where you can type the values of parameters A and B, and then the output would be in C. Then you would have a button that would add A plus B. So if we click on add A plus B, we call the functions add A plus B, which would retrieve the values of the input fields. Notice that it's converting them into integers, right? Because by default, these input fields, they're text fields that you can type anything. We're going to try and parse them into integers, so that we can do arithmetic addition. If we did not do this, these would be converted. These would be by default strings. So this plus here would be string concatenation as opposed to integer addition, right? So careful, right, that things are in the correct data type. Also, we'll be introducing a format called JSON. JSON is a JavaScript object notation, right? That is going to allow us to represent complex data types, that allow us to combine properties and different data types of such as integers, floating point, dates, strings, booleans, right, into this in complex data types. All right. JSON has become more and more popular in the last several years, right? Especially at the turn of the century. Before XML was very popular, right? It was the most everybody, the major corporations were using XML as the format for exchanging data, right? So if two processes were exchanging data, the most common way of formatting it would be XML. Yes. Now more and more, as web applications became more and more prevalent, the Googles and the Facebooks and the Oracles of the world, right? As more and more the client server architecture became, more and more prevalent, the clients usually were JavaScript programs, right? They were running on browsers, and they were already written in JavaScript, right? And there was a lot of effort into converting data so that these JavaScript programs could consume it, right? So there was always a a step in the process where we convert or format everything into JSON so that JavaScript could then do something with it, right? So even if the transport layer would be using CSV files or XML or binary, the last step would always be, oh, let me convert it into JSON because the consumer, the client is JavaScript. Yes. So this became so popular that today, even the transport layer, it's very commonly just JSON format, right? Since you're gonna, and typically even the data storage has become very commonly JSON. We store it in JSON, we retrieve it from the database in JSON, and we transport it through the network in JSON, and then it's consumed by a JavaScript program in JSON, right? So it's become very, very popular. Even if there's no JavaScript, it's become very popular to have something in the .json file. Okay, just like before, it used to be XML, right, in the .xml file. Yes, things just change, and who knows what the next format will be. Yeah. So JSON, it could be as simple as using a literal constructor like this that allows you to create a new instance, right, without the keyword new, right, just with the literal curly brackets, allows you to create objects on the fly, right, declare them there on the spot, which is pretty cool. And then you can use, the very familiar dot notation, right, to access each one of the properties. Yes, so here's a simple house object with 3 properties and 3 integers, and then we are retrieving 3 elements on the screen, presumably that have the IDs rooms, baths, and square feet, right? And then we are writing into the document to display the object. Okay. All right. So let's do some a couple of exercises. Let's get you started. So this is the introduction of the 3rd assignment. Some of you, I see that some of you have already started, and you're well into the lab 3. So I'm just going to do a few, get you going, and I'll stop when there's something interesting, but for the most part they're self-explanatory. Okay, let's see. Okay, so all the exercises we're going to do in this brand new page called Lab 3, and make sure to remember to add them to create a link to the Lab 3 from your root lab page. Yes, and also remember to put it in your table of contents, right, so that TAs can easily navigate to your Lab 3. Okay. All right, so we have that. Perfect. Let's move on. Any questions? Trivial, yes? All right, let's see if indeed our application is running. All right, let's see, Lab 3. Okay. We have a place to start working on Lab 3. All right. All right, let's talk about some trivial stuff. All right, so let's talk about variables, declaring variables, right? Something trivial. So for the longest time, up until 2015, variables were declared with the keyword var, right? And it has since fallen out of favor, right? We don't use the keyword var anymore, even though it's still it's there, it's still supported, right, for backwards compatibility, but we don't use var anymore. Instead, we use let and const. All right. Yeah, so best practice is to just let and const and don't use var, right? Although if you look back further enough, you'll still find code that still uses var, right? Yeah, JSON objects, right? You can declare them using just opening curly bracket, and then you can just declaring these a literal declaration, right? Where you have properties, and then properties can have a mixture of data types, where you have integers, objects that contain other objects that contain other arrays, right? And they can be arbitrarily complex, right? And then you can use dot notation to, to navigate, as you would expect, right? A couple of changes over the years, in particular in 2015, there was a huge leap between version 5 and version 6 of JavaScript, and that really brought it into the modern age, right? For the longest time, right, JavaScript was criticized for missing out on some very crucial and obvious modern features, right? And so here's just a few, right? The variables, right? They were scoped to the outer function, right? As opposed to having a very narrow scope, right? So for instance, we could not declare local variables. Instead, they were declared for the whole, for the whole function, right? So you can change the value of the variable anywhere. But with ES6, we introduced local variables, so you can use let instead of var, and they are declared within that one block, and then they're not, and then they just fall out of scope, when you are outside of that scope. Something trivial, which was we took for granted in every other programming language. Now it became a big thing in JavaScript. And yeah, so there's an exercise, if you could please take a look at that, that plays around with variables and constants. The first couple of exercises tell you exactly what to write, right? The name of the function, the variables, and the return, exactly as is. But as it progresses through the exercises, it gets more and more vague, right? It doesn't declare the function at all, right? In some cases, it doesn't even tell you what the return is, right? It only tells you what the output should be. Yes. So generate the output, right, so that it matches with whatever we're showing you there. If it's close enough, then it's good, right? Don't fuss about it, right? Yeah. So and then import them into Lab 3 so that the TAs can just go through that and confirm. All right. Yeah. A few other things here, just that there are different data types. I guess this one is worth taking a look at. So there's variable data types. Let me just show you this for a second. Variable data types. So lab 3. And let me bring that into Lab 3 page. Variable data types. Okay, so layout. There we go. Some margin looks a little better. Sorry. Yeah, so let's look at the code for a second here. In particular, I want you to look at, first the syntax, right? The syntax is that, you declare the variables, whatever data structure you declare, and the way it's inserted into the user interface is by using these curly brackets, right? And so these curly brackets are basically an escape sequence, right? Notice that everything that is not in a curly bracket, like this div, the header, right, this text number variable, the equal sign, right, is written literally like that in the output. Make sense? But when it gets to the curly bracket, it's an escape sequence. It's saying, hey, the following is not literally number variable, right? It's whatever that expression evaluates to. Yes? So evaluate this expression, convert it into text, right? And then append it to the output. Yes? And this one turns out to be, 1, 2, 3. Everybody good? Right? Well, that's trivial, right? What I do want to point out is here, this Boolean variable. This Boolean variable doesn't quite behave the way I said. Right? Boolean variables have the value of either true or false, correct? And it's printing here as the keyword true, yes? But notice that to force that, I've had to append here a empty string. Notice if I remove this, it doesn't print anything. It's empty. See that? Right? So what I've had to do is to cast or force the value true into its string representation by concatenating to a string, right? What it's doing is that internally it's converting the keyword true into its string representation, which are the, the letters TRUE. Yes, right. Now you might say, well, why is that? Why does the string variable and the number and floating point? Why don't I have to do that for those? Well, that's actually a feature. Right? A feature of React is that by default, okay, Boolean expressions, when they evaluate to true and false, they don't evaluate to their string representation, right? And that's very important in the next couple of exercises, right? But I just wanted to point out, right, that is a feature, right? That if I do want to see it, I need to force it into its string representation, which is what this is doing, right? And that feature is very useful, as we'll see in a minute. Okay, so here it is for Boolean variables. So Boolean variables, this is just going through several Boolean expressions, just pointing out all the common Boolean operators are there, the ands and the ors and the nots, as you would expect. Yes, and also all the greater than and not greater than, they're all there as any programming language. What I did want to point out is the triple equal. Okay, so this is the triple equal comes from a vestige a feature, I guess, or flaw of the language, where you have the single equal means assignment, right? So you assign the right value to the left value, and then there's equal equal, like any other programming language, means that you are comparing. You're saying, are the two things that I'm looking at, are they equal to one another? Yes. Well, in JavaScript, equal equal behaves slightly different, right? Not exactly as you would expect, and that's why we need a triple equal, right? But so let me just tell you about the equal equal, and then this will be the last time I will ever talk about it. Never use the equal equal. Okay, it has the bad feature, right, that it will try to cast, right, one of the values on either end, right, to the other side, yes, and then compare whether they're equal or not. Okay, so for instance, if you do character 1, is it equal to the number 1? Well, obviously not, right? They're not equal. One is a character and the other is an integer, yes? Well, what JavaScript will try to do is to cast one into the other, right? And then it will compare. And sometimes it happens that one casts the other, they are equal, okay? And this was a source of bugs, a huge source of bugs, right? When you meant that you wanted to be, to be certain that these two things were equal, they weren't really equal, they were sorta equal, okay? And there comes the term truthy. Is this true? Well, it's truthy. It's not really true, right? It's sort of true, yes? So this was a really huge source of bugs. So don't use the equal equal. Instead, use the triple equal. The triple equal will first compare the data types, okay? If the data types are the same, then it will check to see if the values are the same, yes? If the data types are not the same, it won't even bother comparing them, right? It will immediately say false. Make sense? So yeah, so careful. Always use triple equal, all right? Same thing with the not equal. There is the not equal, and there's the not equal equal. Okay, same thing there, right? Don't use the not equal, use the not equal equal, okay? All right, so just be careful there. Other than that, everything behaves as expected, and now already know the reason why I've concatenated the two quotes here, right? Right, because again, to show true false, I had to cast it into its string representation. Everybody good? Right. All right. So it should behave like that. All right. So here's why Boolean expressions, when we try to evaluate them, right, when they try to render on the screen, they don't render like anything, right? They're blank, right? And the reason is that a very common use of Boolean expressions is to use them in tandem with HTML. Right? It's very common that you do a Boolean expression of not just Booleans values, but a combination of Boolean values with non-Boolean values. Okay, like over here, right? We are doing the AND operation with, on the left side, you have a Boolean expression which evaluates to either true or false. Yes. And the right-hand side, a non-Boolean expression, which is a paragraph. Make sense? Right? And what this does is that it either renders this or it doesn't render this. Right? If this is true, then this gets rendered without the keyword true. Right? It would be inconvenient, right? If if this would be evaluate to the keyword, true, right? We would have to, somehow remove it from the string, right? But right, in all its wisdom, right, the React folks, right, decided to, oh, this would be a really cool syntax, right? If you want to toggle something that is display or don't display, you just AND it with a Boolean expression, right? And if that Boolean expression is true, then the right-hand side gets rendered, right? If it's false, then the right-hand side doesn't get rendered. Make sense? It's a very, very convenient, and you'll see this all over the place. It's a very, very common syntax where you have a Boolean expression, ANDed or ORed or whatever, right? With the right hand, well, not ORed, because then the right-hand side will always be true, right? It will always render. ANDed, okay? So if true one is true, then this gets rendered. If this is false, then this does not render. Okay. Same thing with ternary expressions, right? It's a very common syntax where you have a ternary expression where you have the Boolean expression can either be true or false, and then the two options, right? The true option and the false option, right, are some HTML or some component, right, that renders one output or another output. Yes, right. So this says if maybe if I'm logged in, it says welcome. If I'm not logged in, it'll say please log in. Yes. Right. Again, very, very common syntax. You'll see it all over the place, right, in React programs, right? So yeah, so here's an example of the ternary expression where logged in is either true or false, and it either welcomes you or asks you to identify yourself. Yes, right. Very, very common syntax. Okay. All right. Yes. Okay. So conditional outputs, right? Up to this point, all our components and pages have always had just a single return. Okay. Well, you can have multiple returns, right? Whatever return you have, that's what the component is going to render. So here's just an example, a trivial example where you have either one return or another return. So this component will either return welcome or please log in, right? Where you have an if statement that says, well, either return this or return that. And the component will render one or the other. Very common thing to do. Yes, where you have some complex computation, blah, 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 and then you either return one thing, right? One complex output or one other complex output, or several. You might have a switch, right? Depending on that switch, yes, and you have several case statements that will render one. You'll return something or another. Yes, right. Very, very common. Now, more common than this. Now, this syntax sometimes is very, very hard to read, right? Where you have all these if statements, interspersed with a whole bunch of returns, if else, return. That oftentimes is very hard to read. More commonly, folks will use this comparable syntax, which is maybe a little bit easier to read, where you have just a single return, and within the return you have the logic, right? So as opposed to having a logic and then the output is the returns, you have backwards. You have one return, right? And then inside you have the logic where you either render one thing or you render another. So for instance, if logged in, you render one thing. If it's not logged in, you render something else. Yes? Right, this is, sometimes folks prefer this syntax, right? It's a little cleaner and basically it does the same thing, right? The output is identical. Okay, makes sense? This is more of a, a stylistic choice, doing one way or another. Okay, all right. All right, let's talk about functions. So functions was one of the biggest leaps, right? Going from version 5 to version 6. Okay, and so one of the choices, or one of the design choices, or goals of upgrading functions was to make functions more terse, more compact, right? Having the syntax so that you could say the same thing but with fewer characters, with fewer lines. Okay, in particular because in JavaScript it's very common to have lambda functions, functions that are anonymous, right? That don't have a name, right? Where you maybe you're in a tight loop, okay, and you need to do a computation, and you declare the function right inside of that really tight loop, right? So instead of declaring an outside function and then calling it multiple times, you just declare it inside of that loop, right? And once you're done, that function doesn't exist, right? It's gone. Yes, right. That's a very, very common syntax, right? That has evolved in JavaScript for quite a while, and so it's very useful if in that tight loop, the syntax would be fairly compact, right? So one of the things that they've done away with is the keyword function. Okay. Now this doesn't mean that we are throwing away the old syntax. This syntax here on the left is still widely used. Okay. But we get a new syntax here on the right-hand side, right? It's an alternative syntax, right? Which can do everything that the old syntax does, plus a few other things. Okay. One of the things is that it does away with the function keyword. Okay. Instead, you declare a variable, right, or a constant, and then you assign a function that is declared here on the right. So the right here is declaring a function that has no name. Okay, it's anonymous, and it returns something that is of type function, which is being assigned to a variable or a constant, right? That now whose data type is a function. So the data type of this variable here is function, right? Just like you can ask a string, what data type are you? Oh, I'm a string. You're a number, right? And you're a Boolean. Oh, you're a function, right? Variables have different data types, and JavaScript has made an effort at treating functions just like any other data type, right? You can pass you can pass numbers, right, and strings and dates and booleans to other functions. Well, you can also pass functions to other functions, right, with the same simplicity, the same syntactic simplicity, right? So notice there's no function keyword, right? Instead, here we declare the data types A and B, after the keyword function. Here, there's no keyword function. You just declare the same, a parameter list, right? And then the arrow is where the declaration of the actual body, right, of the function begins, right? So these are called now arrow functions, right? Arrow functions, because of the distinctive, arrow key characters here, equal and greater than. Everybody good? Right? Other than that, they behave the same way, right? You would call them the same way. So here's a couple of examples of using them, but in particular, how now the syntax can be much more terse, much more compact, right? So here's a function, add ES5 with A and B, and here's the equivalent in a single line. Yes, right? Now, if your function is as trivial as this, if something is trivial as you have a single return of A plus B and there's nothing else, right? There's only this return A plus B, right? The new syntax allows you to be more compact and say, hey, this is the only thing you're doing. You are adding a plus b. And right, and so that's the only thing you're doing. You can just drop the return and the curly brackets, right, and just say a plus b, right? Notice how much more compact the syntax is. See that? Right? No need for the return, no need for the curly brackets, just a plus b. See that? All right. So that's what we call implied return. There's an implied return in here. See that? All right. All right. So that's one thing that makes it, much more compact. Now this only works if the only line, right, of the body is a return. Yes, that's the only time you can do that. You have to be careful, because oftentimes, you'll write a function that only has a return, and you say, I can use the new syntax, right? And you'll write up the syntax, and then you'll realize that, because you've removed the return, you can't add a breakpoint anymore. For instance, you can't step through this, right? You want to it's returning the wrong value, and says, why is this not working? And you want to put a breakpoint, and so you say, oh well, to put a breakpoint, I need to put back the previous syntax, right, where I had the return, right, and so you put it back with a return, right, and then maybe you put a console log in there, right, to see the values of a and b, to find out why 2 plus 3 is not 5, right, it's 6 or something. Why is this happening? You want to print out the values of a and b, okay, and now you fixed it, and now it's working, and you want to go back to the original, to the more compact version, and you remove the return, you remove the curly bracket, but you forget to remove the console. Yes, you forget to remove the console, and now all of a sudden your function is not returning anything, it's just printing out the console, because that is the only line that's really the body. You see that? That's a very common mistake. Careful, right? Going back and forth between these two syntax. Yes, especially if you want to step through it and you're debugging it, it happens more than you know. Okay, so careful there. Yes. Because then it's 2 lines of code, right? You can only do this syntax if you only have a single line of code, which is the return. When you do the console, now you have 2 lines of code, right? So when you remove the curly brackets again, now the single line is not the return, it's the console. And the return is like hanging there. It doesn't belong to anybody, right? And so it's still returning, right? But it's not returning from your function call. It's returning from maybe from a higher context. Now the return is outside of your function, right? It belongs to someone else. Right, you haven't removed the return because that was really your only line that you cared about, right? You only had added the console because you were in the middle of a debugging, right? And then it happens quite often that, hey, it's just 1 line. Here you have 2 lines. Another syntactic improvement, I guess, although some folks don't consider this an improvement, is that if your function has a single parameter, right, like for instance, you have b here, right, that's the only parameter, then you can optionally drop the parentheses, right? You can drop the parentheses and just do b arrow b times b, for instance, right? Now, people are debating over this on whether this is even a good syntax or a good practice. For instance, your IDE, you will oftentimes will replace this and force you to put the parentheses in between, right? Since folks are debating whether it's actually easier to read with the parentheses than without the parentheses. Okay, so yeah, there's some debate there. And, I think in a really tight loop, right? It's actually very useful not to have the parentheses there. Okay, but yeah, I mean, you should be able to choose. Now the this keyword here was the biggest reason why the change, right, to this better version of the arrow function. Okay, in the previous version, still today, in the if you are using the legacy or the older function version, right, that this keyword behaves differently than what you would expect in any other programming language, right? In every other programming language, that this keyword always references the instance object that you're in. Yes? And that's the only value you should expect. Not in JavaScript, right? But this keyword moves around, okay? It is tied to the nearest function instance, right? So that if that function calls another function, then when you're inside that other function, that this keyword no longer points to the outer context, it's always the innermost context, right, of that function, which is a pain in the butt, right? Coming from any other programming language, object-oriented programming language, you instantiate something, and this keyword is always tied to the object instance, not in JavaScript. So in the newer version that doesn't use the function keyword, this keyword does behave, right, the way you would expect, right? It's always tied to the outer instance, okay? But only in the new arrow syntax, right? In the older arrow syntax, it still behaves the way it always used to behave, okay? Right? So if you need this keyword to behave the way you would expect, right, then use the new arrow syntax. If not, doesn't matter which one you use, right? Whether you use the arrow function or you use the function, right? You'll see me use back and forth, one syntax or another syntax. Like for instance, I prefer the when I'm declaring pages or I'm declaring components, I prefer the older function syntax. But if I'm using event handlers, or I'm in a tight loop, or lambda functions, right, I will typically use the newer syntax. Or if I need this keyword to behave as I would expect, I will use the new arrow function. Now, there's nothing that the older syntax can do that the new syntax can't, right? So you could very well just do everything using the new arrow syntax, right, and just forget about the older syntax. But you will find a mixture of both, right, in all React components. So we might as well, right, just use both, right, and just be careful, right, only when we have to deal with this keyword, which will not be often, right? It will not be often, so it'll be okay. All right. A few other things here and there. The default parameters you can give in the syntax. In the parameter list, you can put default values like y7, z42, so that when you call the function, you can optionally drop those attributes, those parameters, right? If you don't pass them, then it will take those default values. Yes, that's syntactic sugar. All right, a couple of exercises here. We have a couple of examples of using the old legacy functions where here we have our component, which is going to call our old syntax add function, right? We're passing values 2 and 4. Notice that because we're using TypeScript, right, the functions are going to force us to declare the data types of the parameters. See that? Number. Up to this point, we haven't been having to declare any data types, right? Up to this point. But because we're going to start using functions, right, we want to make sure that the compiler, right, or the transpiler can catch any errors when we are passing parameters to a function. Yes? That was one of the big complaints against JavaScript, that it was not typed, right? You could very easily just pass in any data type, and there was no type checking. Yes? Right? And so this would you could easily write buggy code that you were passing the wrong data type to a function, and you would not catch this until runtime, right? You would have to run the program, it would crash, and then you would find out what went wrong. As opposed to now with TypeScript, you can catch these errors earlier, right, while you are developing, as opposed to when you're running it. Yes, right. So it's something you would expect in any modern programming language. Okay, so this is add, right? Add 2, 4, and it behaves like you would expect, right? You call the function 2, 4, right, and then it returns the 6. And but then you can also call it from within the curly brackets, right? Embed it inside of HTML, Yes, right. So this is evaluates. You call it, right, and then it returns the value and it gets replaced. Okay. So yeah, so it behaves as you would expect. Now here is the alternative syntax where we are declaring subtract using the new arrow syntax, right? We have a number b, right? Value of a minus b, and notice that the syntax to call it is identical, right? Use a constant and then the parentheses to call it, and same thing when you're calling it here, 3 comma 1 and whatnot. Yes, everybody good? Right. So the syntax from calling it is identical, no change there. Multiply. Here's just pointing out the fact that because the return types are so simple, right? We're just returning a minus b. This is a good opportunity to use the new implied return syntax. Yes, just so here we have multiply. Instead of using curly bracket return a times b, we just have right arrow a times b. Yes, right. Very, very useful syntax. Everybody good? All right. All right. So let's look at string interpolation. Okay. So this feature, right, comes from the fact that it's very common that we need to generate long text that has embedded values that are computed on the fly, right? And the most common way that we know how to do that is to have strings with concatenated expressions, concatenated variables, right? Where you use the plus sign to combine expressions with strings, with expression, with strings, and whatnot. Yes, and we've said already that that's very error prone, right? Whenever you're using the concatenator, the plus sign, right, you can very easily make a mistake, right? So this new syntax introduces another quote, right? We know that we can use the single quote, we can use the double quotes, right? And so in JavaScript they're interchangeable. You can use single quotes inside of double quotes or double quotes inside of single quotes. Okay, and so what JavaScript does is that it introduces a new type of quote, the backtick, right? The backtick allows you to embed not only text, but it allows you to embed expressions, right? So for instance, here you have an opening backtick right here, and here you have a closing backtick here. See that, right? And in between, you can mix and match text, expressions, more text, more expressions, more text, more expressions. The expressions now need to be escaped, right? The way they're embedded is by a combination of $ curly brackets. See that? This makes it so much more easy, right, to concatenate and embed content without, right, the concern of inadvertently using the quotations and the plus sign to make a mistake. Okay, right. Also, especially when you have really long strings where there are multiple lines, right? Typically, you would have to close the quote, right, and then do a plus, and then do a open quote. So that is just horrible. Here you just have you can open up a backtick, right? Have multiple lines, and then close the backtick, right? And then they can right have as many lines as you want, right? Without having to open close, right? So it's very, very convenient. And we're going to be using this quite a bit, especially when we are styling content, right? When we are adding a class, right? Or we are adding a style attribute, right? When we are highlighting something as you're clicking and dragging, yes, we are programmatically choosing to add a style, a class, a property, yes, right? And we're computing that for those values. This will be indispensable, right? To be able to, create these dynamic classes. So here's just a simple exercise where you get to play around with with these strings. Okay, greeting, welcome, and then the username, logged in, and you have an expression, like a ternary expression that renders yes and no. So arrays, we have a full support with multiple functions that allow us to manipulate arrays. Now, most of these functions, they don't manipulate the actual array. What they do is that they either compute a new array based on the old array, or they compact a single array into one value. Right? So, for instance, filter can take an input array here, all the numbers 1 through 10, and dot filter. What it does is that it computes a new array. So this is the original array, all. Filter takes the original array and computes a new version of that array. What it does is that you give it a function here. You give it a function, which is now a predicate. What it does is that iterates over the old array, passing each item to the function, and if that function evaluates to true, we keep that value. Right? If it evaluates to false, we skip over that value. Make sense? So, for instance, this function, right? We're using the new arrow, right? We're using new arrow syntax, yes. And so filter gets the value of 1, 2, 3, 4, 5, all the way through 10. Yeah. As we're going, we are computing whether that value is divisible by 2, basically. Yes. Yeah. Yes. No. Yes. No. Yes. No. So basically, this is returning all the even values, right? You get 2, 4, 6, 8, and 10. And this one, notice this is using the more compact syntax, right? Using the no parentheses in the parameter list, yes, right? It's using the implied return, so no curly brackets, no return keyword, yes, right? So this is saying, if it's not divisible by 2, right, return true. So basically, this is returning all the odd values. See that? And also this is illustrating how much more compact the new syntax is, right? You see that? It would be even worse if I had to declare this to be use the keyword function, right? It would be even longer, right? So the new arrow function is by far, very much more compact, much more terse. You can say the same thing, with fewer keystrokes. Yes, it's also much easier to read, right? Much easier to read. So yeah, it shines. The arrow function shines most when it's a lambda function, right? That's embedded, right, in some other function call. Right? And this is where the arrow function was, specially designed for. All right, here's a few other, right? Just pointing out the fact that how much more readable the new version is, as opposed to the old version where you had the keyword function, you had the parentheses, the curly brackets, the return, right? This is so much more harder to read, right? It's so much more verbose, right, than the new syntax. Okay, so how about this? Yeah, so we have yeah, okay, though this was pointing out the fact of careful when you are debugging and you start to remove things, right, and you put them back, and you have this console. Careful, right, that that this only works if it's a single line, right? The implied return. Okay, map. So map, like filter, it computes a new array, right? None of these functions manipulate, right, the old array. Okay, these all compute a brand new array. Right? So map computes a brand new array. Now filter computes usually an array that is shorter, right? That has less elements, right? Because it's filtering out some elements out. Was map returns an array that is of the same size, right? But the elements are different. The values of the elements in the new array are different. The new items are a variation or a computation from the old items. So what we're doing here, for instance, is that we're giving it a function where we give it how to compute each item. So each item is going to be the old item multiplied by itself, right? So if you had 1, 2, 3, 4, you get 1, 4, 9, 16, right? So the squares, you get all the square values. Make sense, right? Now we're going to be using map quite a bit. Filter, map, these are going to be our bread and butter, right? We're going to be using this, very, very often right, all the time, right? As we iterate over data types, right, we're going to be computing, right? We're going to be computing what the user interface should look like, from a given data structure, from some JSON object that we're have on a file, or data that we have retrieved from some database, right, or from some server, right? And then we iterate and we filter, we map, and our output here is going to be HTML. Right, we get it. Our input will be maybe some object. Maybe we're going to iterate over the courses array of courses. As we iterate, we get each one of the course objects, and our output will be maybe some line item, right, where we display a column instead of a row, right, that displays the title of the course, right, the description of the course, how many seats, blah blah blah, and whatnot. Yes. So that's where we're going. Yeah, a couple other things here. Find. There's two versions of find. There's find and find index. Find, it finds the item as it's looking for it. So if you have an array 1, 2, 3, 4, 5, and you're looking for the value whose value, find me the value x whose value is greater than 3. So it iterates and it finds 1 is not greater than 3. No, 3 is not greater than 3. It finds 4. So this whole thing evaluates to 4. It finds the first item whose predicate is true. Yes? Right? And whereas find index doesn't return the item itself, but it tells you where it is, where in the array it is. So this returns 2. It's in the 0, 1, 2. Okay? And careful for filter with x is greater than 3, meaning find all the items, filter out all the items. I only want the ones that are greater than 3, so you only get 4 and 5. Yes? So careful. Same predicate, different outputs depending on the function. Yes? And so this will, you'll get questions like this in the quiz, right? I'll give you a whole bunch of arrays, a whole bunch of functions, and you have to tell me, well, what's the output? Is this this? Is this the other one? What is it? Okay? All right, couple of exercises. So simple arrays exercise just shows you, iterating over some arrays. Also, here's just a simple, number array, an array made of strings, and then an array made of line items. How cool is that, right? Again, here's just an example that the language that we're using is a combination of TypeScript and XML, right? Which tries to blur the line between these two worlds. Yes, we have a normal array here, which would be JavaScript or TypeScript, and notice that the items is HTML. See that? That's pretty cool. So here's line item 1, line item 2, and here's another array that just mixes and matches all different data types. Variables, constants, numbers, arrays, strings, right? And then how they output, right? So here's a number array. Now, I guess number arrays, when you print it out, it prints out 1, 2, 3, 4, 5 without the square brackets, without the commas, which is very important, right? Just like when we looked at true and false, like the Boolean values, when they render on the screen, they render like nothing, right? They get removed from the as a string, right? We have to coerce it into a string to be able to see it. Yes. Same thing here. The array in bare bones JavaScript, the array would be printed literally with the square brackets, right? The numbers and all the commas. Yes. That is how native JavaScript prints something on the screen. Arrays. Yes. It converts them to a string that has the square brackets and all the commas and the extra spaces. Yes. But in TypeScript, it's actually very inconvenient to have the square brackets and the commas. Ideally, it would be just the concatenation of all the items. And this is exactly what it does, right? When it prints out an array, right, to the screen, what it does is that it concatenates all the items, right, and it prints that, converts that into a string, and then adds it to the DOM. Yes, right? So this prints out as 1, 2, 3, 4, 5. String array, same thing. It concatenates string 1 with string 2, and that's what you get, string 1, string 2, right? this variable array, I don't have a picture of it. Variable array is just the string concatenation of everything. 2, 5, minus 3, 1, 2, 3, 4, 5, right? String 1, string 2, right? All one big long string, right? No square brackets, no commas. That's very, very important. Why? Well, here it is. That feature of dropping the square brackets and the commas is actually very convenient. Notice what happens here. OL. See that? Open item, OL. And then here I have an array of line items. See that? So the output is just what? OL, right? Concatenated with the line item, concatenated with the line item, and then the closing OL. See that? No square brackets, no commas, right? If it added the square brackets and the commas, we would have to go back and edit that string to remove the commas and to remove the square brackets. It would be very inconvenient, right? But because it does that for us natively, it's very convenient, right, to mix and match, okay, arrays, objects, and HTML. Yes, very, very convenient. This is just a array index, so you can do this. This is trivial. Manipulating arrays. Well, I said earlier that all functions computed new arrays did not manipulate the old arrays. Not true. Push and pop and splice, they do update or manipulate the original array, right? So push just appends an item at the end of the array. So push 6 here, it's adding just 1, 2, 3, 4, 5, 6 at the end. This string array is adding string 3 to the end of this array. And this to-do array is pushing this new line item at the end of this to-do array here. So it's adding a new line item, yes? So push does that. Splice can do both things. It can either remove an item, right? Or it can add a new item. More commonly, it's used for removing items, right? The way it works is that if you only have 2 parameters, it's removing. Right? You say what index you want to remove, and then how many items you want to remove. If it has a third item, it's actually appending or adding, right, a new value at that position. Okay. But if you want to splice right in the middle of an array, you can insert right in the middle. So splice allows you to do that. I don't have an example here, but yeah, no, this is just showing you that you can add and remove items, right, and just display them. So play around with that. Loops is what you would expect. Map functions. So here's an example. Here's where we start getting into what we're actually going to be doing with map, right? So map here, we're using it for what we saw earlier, displaying the square. But more interesting is what we would expect to use it inside, in the middle of an HTML, where we have an opening long expression here. Notice the curly bracket, closing bracket, see that? Right? And then we're iterating over the to-dos. And as we iterate over the to-dos, we are creating the output to be new line items, embedding the new to-do item in there. See that? Right? So this is more common what we're going to be using map for, right? We're going to be iterating over courses, modules, right? Lessons, assignments, yes, right? People, right? And as we're iterating over them, we're going to be adding, cards or rows, right, for the people, or assignments, objects that render the content, of our pages. Yes, right. That's the more common using. Find. You can play around with find, filter. Okay. Keep talking about JavaScript objects. Right. As I mentioned earlier, right, you can create objects by using the object literal syntax, where you can declare a constant or variable and just use plain old curly brackets, right, and declare name value pairs, right, separated by commas, right, and the properties can be different data types, including nested objects, nested arrays, right, and you can intermix data types. Like an array could have a string data type, then a number, then a Boolean. There's no typing unless you declare, assign it to a TypeScript type, right? And then you can use dot notation to retrieve and print out each one of those properties to the screen, right? And now oftentimes, right? I didn't mention that, right? If you're trying to print out an array to the screen, by default, what React does is that it concatenates all the values, right, and then converts that into a string. Please. Right. So, right, that's the default behavior, is to concatenate all the values and to print it out to the screen. Yes. But oftentimes you want to literally print out the actual data representation, right? So to do that, there's a utility function in a global object called JSON. So JSON is a collection of utility functions that deal with JSON objects, right? Allow you to convert objects into their string representations, or vice versa, string representation into their object equivalent. Right? And it comes in handy specifically for debugging. For us developers, it's very useful. So here's a couple of examples where, for instance, you can stringify the squares, which is an array. So it converts it first into a string representation, and then it prints it, as opposed to parsing the array, throwing out of the commas and the square brackets. This one renders literally the square brackets, the values, and with all the commas, the way that native JavaScript does, right? As you would expect, the native representation. So that's useful. If you're debugging, right, you want to look at the data type of the object right away in the screen while you're working to make sure that the values are what you're expecting before they get processed by all the magic, right? You might want to see what the code, what the data is, right? So here's an example of just iterating over an array, and something that you might find in one of the exercises, right? You have an array of to-dos, right? And these are stored in a JSON file. Notice there's no JavaScript here, right? There's no function, there's nothing. It's just the raw array and nothing else. Okay. Notice that the arrays, when they are declared in TypeScript, notice that the properties, the objects and the arrays within, and objects within arrays or objects themselves, the property names don't use quotations. See that? Like, for instance, here, this object, notice that the property names don't have quotations. See that? Right? And that's syntactic sugar, right? In TSX, you are allowed, the quotations are optional. Right? You don't need the quotations. It's understood, right, that the property name is quoted. The values themselves can be numbers, so they don't need quotes, yes? But if it's a string, obviously you do need the quotes, right? If it's a true or false, you use the keyword true, false with no quotes, right? But in a JSON file, you do have to follow the strict JSON formatting, right, where properties are also quoted. Right? Now, in JavaScript or TSX, you don't have to quote them, but you can if you want, especially if the name is some weird name, right, where you want to use maybe, I don't know, a space for the name of the property. You can use space for the name of the property, but then you have to quote it. Right? You can use underscore, dashes, right? These would be all invalid names, right? In camel casing, in camel casing, you cannot use dashes or I guess no underscores, no spaces, no weird characters, but you can still use them, right? If you quote them, right? But typically it's a bad practice. You don't do that in general. But here, the quotations are not optional. You have to add the quotations, unless there's some data type, right? True, false. Those don't need quotes. Numbers don't need quotes. Right? So here's an example of. For instance, notice that we're using, for the declaration of this, this is a component. This is a component. Notice that I'm not using the function, the legacy function keyword. Instead, right, the component is using the new arrow function declaration. See that? So I'm not declaring function, to do item, and so on. Yes, right. And instead, we're using the new syntax: cons to do item equal. This is the parameter list, arrow, and this here's the return. Yes, see that? So it's using the new syntax, and you could certainly just only use the arrow functions from now on if you prefer that new syntax. Okay, here I'm just just letting you see that the feel the new syntax. This return actually, because this function, the only thing that is returning is this one li. Okay, we could drop the return, right, and just have a parentheses, drop the semicolon, drop the curly bracket, and just have that arrow, no curly brackets, no return, just a parentheses that holds the li. Right, we could do that. Right, it might look a little weird, okay, but it's an arrow function. Right, you can, if that's the only thing that you're returning, then yeah, that still applies. Okay. Okay. Then. Okay, here I'm getting a little ahead of myself. But notice the parameter list. The parameter list, notice that it starts off with a curly bracket. See that? It starts off with a curly bracket and the declaration of a property in that curly bracket. Okay? And here's it's initialized. This variable or constant is initialized with an object whose properties are done, title, and status, with values done true, title is buy milk, and status is completed, right? Then there's the closing of the JSON object, and this is the closing of this curly bracket over here. See that? Right? That outer curly bracket, we have to yet see what that means. But a hint is that we are expecting that you are passing us an object, right? And we're expecting that you are passing us an object that has a property called to do. Okay, and it's whatever you pass us, whatever object with property to do is going to be bound locally to this local const property to do. Yes. And then internally, we are going to return an li line item with an input field, checkbox, right, with initial value, whether it's checked or not, based on to do is done or true or false. And then printing out the title of the to-do and the status, whether it's completed or not. Yes? So, and then the output, so the whole output is basically one big line item. Everybody good? Right. So this line item, okay, and then obviously also, because, in a function, you would normally do, export, default, function, yada, 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 right? But that's not valid when you're using arrow function. You have to do the export default later at the bottom. Okay, so the syntax is slightly different when you do the export and the default. Typically, you would do export default function to do item. Yes. Right. Okay, so we're importing the to do item right here, like we normally would, right? We're importing the to dos, the JSON object, and out here we're also using the arrow function to declare a component called to do list. Right, that takes no parameter and it returns the following. Okay. Okay, what does it return? Right. First, it returns these little weird opening and closing tags that have no name. See that? See that? Right. Typically, we would use what? A div, maybe, right? As a wrapper around. Now, sometimes we don't really know if this should be a div, should be a span, should be a. What do we want to wrap this whole thing with? Yes? Okay? How is it that we're going to wrap it? Now, oftentimes we don't want to wrap it with anything. That the only reason why we're wrapping it is because the return function needs to have a single return item. It can't return more than one thing. So it has to be wrapped in something, right? It needs to be wrapped in something, typically a div. But this one says, okay, well, the only reason I'm wrapping around is because return needs to be a single thing, but I don't actually want to add anything to the DOM. Right? If I put a div there, the div is actually going to be a node in the output DOM. Yes, in the resulting DOM. Right? if we use this new this is called a snippet tag, right? What's going to be added to the DOM is literally the H3, the UL, and the HR, but no outer element wrapping it, right? That's very, very common, right? If you're iterating over something and you need to wrap it with something, but whatever you're wrapping it with is incompatible with the parent. Okay, for instance, this UL expects a whole bunch of LIs in here. Yes, this UL expects so whatever this is doing needs to be able to return an array of line items. Yes, right. So, and here's where the line items are being generated. Yes, right? But say that as I am computing this return, I need to wrap this, right? Because I need to add some other thing, and wrapping it with a div would make this incompatible with my parent UL. See that? Because UL is expecting an array of line items, not an array of divs. Make sense? Right? So here, if I need to wrap it because return needs to have a single thing, I would use snippets, opening and closing, because I don't want to add anything outside. Right? I don't want to add anything because then I would make it incompatible with my parent that's expecting only LIs. Make sense? Right? So snippet is very, very useful if you want to group things together logically, but you don't want to necessarily add anything to the DOM. Right? You don't want to render anything in the screen. Okay. So I'm displaying a heading of to-do list, a UL, and then here I'm going to iterate over the array of to-dos. As I'm iterating, I get each to-do item, and I pass the to-do as an attribute into the to-do item. Okay, again, this is a new syntax. Right? To-do item is basically this guy, to-do item, which is receiving a reference to the to-do, right? And then in here, it's computing the line item based on the to-do properties done, title, and status, right? Which we're passing one at a time. Everybody good? So basically, UL, this ends up being just an array of a whole bunch of to-do items, and each to-do item is really just a whole bunch of line items. So this ends up being UL with a whole bunch of an array of line items. It drops the square brackets, it drops the commas, and it's just a concatenation of line items, basically. All right, let's talk about a spreader. Okay, so with the same goal of making the language much more compact, much more terse, right? Several new operators were added. The spreader and the destructor, not the destroyer, the destructor, right? So let's take a look at these. Right? So first, spreading. So spreading is a operation that allows you to easily copy, complex data types amongst each other. Right? It's a very common operation that you have a source array, and from that source array, you want to create a target array. You want to create a version of a new array based on the old array. Yes, it's a very common operation. Okay? And same thing with an object. You have a base object, and you want to create a new object where, and you want to inherit, right, or copy over a whole bunch of properties from an older or source object. Okay, and so these are very common operations. So the language added the ... or the spreader operator. Okay, the ... is a new operator that works as follows. Let me give you a couple examples. So here we have a source array that declares 3 items, 1, 2, 3. And then array 2 is a target array where we want to use array 1 as a source. Right? We want to copy over all the items that array 1 already has. Okay, and then we can add additional values. So array 2 ends up having values 1, 2, 3, 4, 5, 6. Okay, it literally copies over and reinstantiates, does a deep copy of the old values onto the new ones. Right? This is not a referential. It's not reference. It's a literal copy of the values. Okay. And same thing for objects, right? So we have objects, A1, B2, C3, right? You can have a new object, object 2, where we copy over the old object, right? And here we're putting it in front, and then we are adding a few other properties, right? D, E, and F. Everybody good? Right? Now and the copy can happen anywhere. At the beginning, you can put it at the end, you can put it in the middle, right? Or you can do it multiple times. You can do it at the beginning, put some values, and then at the end again, right? And it'll spread it, right, as many times as you want. Make sense? Right? And same thing for objects. Now, with arrays, it's trivial what's happening. And the reason is that the values don't need to be unique, right? It's okay that the values in array 1 are also in the array 2. It's okay, right? You have 4, 5, 6 here, and then you would have, just the values duplicated. Yes, no problem. It's okay to have the same values multiple times in the same array. Yes, no problem there. Also, in an array, the positions are unambiguous, right? There's always a first item, a second, a third. The positions are unambiguous. Who ends up in what position? Yes, right? Because the positions are very well defined, always as 0, 1, 2, 3, all the way through the length of the array. Yes, the positions are always that. Now, in objects, there are no positions. Yes, and although the values could repeat, the properties can't. Right? The properties cannot repeat, so you have to be careful when you copy from one object to the other, where you might have a collision, right, of property names, right, where one source object declares a property, and then the target object has the same exact property. Yes, there's a collision. So you have to decide, how do you resolve those collisions? So here's an example where we have, object 2 has, we have a D, E, F. There are no collisions because A, B, C, and D, E, F, they're all unique. Yes. So the names of the properties is the equivalent of the positions, right? Whereas in the array, the positions are unique. There is no collision. In the objects, the positions could have a collision, right? Because those are the names of the properties. Make sense? So here's an example where I have created a collision. You have object 1, you have A, B, C, and then you have B again. See that? Right? So this B is colliding with this B. Right? And basically the rule is that last one wins, right? Because B4 comes after B2, then you end up with A1, B4, and then C3. B2 disappears. Yes? Everybody good? And this is an essential feature, right? We're going to use that feature where you are overriding, prior values. That is going to be used quite often, especially when we start working with forms, right? And we are editing long forms with a whole bunch of properties, right? And we are typing here, we're typing there, right? It's a very common strategy to use this particular feature, right? Often to be able to rewrite the object and update the single property. Yes, right? So let's understand how it works, right? And just be careful, right? It means that always careful, right? The last one wins and overrides any prior objects, right? Or property values, okay? So play around with this. Maybe make your own examples. Make sure you understand how it works. Try, right, creating one and then the other in different orders, yes? And make sure that you understand why the end result is the way it is, right? Here's just a simple examples, but you play around with it, make your own examples until you're sure you understand the way it works, okay? Okay, now let's talk about destructing. So destructing is, again, with the goal of making the language more compact, more terse, right? To be able to do more with less, right? The language added the syntax of destructing. So here's a use case where we would use destructing, right? So in other languages or in ES5, you would declare, for instance, an array. First, we'll look at arrays, then we'll do objects. So first, arrays. So here's array one, list with 1, 2, 3, and it's very common that you copy over from one of the array items, you copy it over into some local variable A and B, right? So list 0 is now 1, and B is list 2 is 3. So A is 1 and B is 3. Yes? It's a very common operation, right? We do that all the time. Another very common operation is that we want to swap two values in the array, right? Or maybe two values into two variables, so that you would declare a temp variable. We swap the two, and then we bring the temp back to B. Yes? So we're swapping two values. Very common, right? Well, with the new syntax, you can do the following. From the same list, right? Instead of using the arrays on the right-hand side, right? So arrays on the right-hand side of the equal sign it's constructing the array. It's building the array. It's declaring the items in the array, correct? But an array syntax on the left side of the equal sign, see that, is destructing the array, right? Not destroying the array. It's not like it's removing or deleting the array, right? It's grabbing portions of the array, right? It's deconstructing. Right? It's grabbing different items in different positions of the array, right? So this one says that A is taking the position 0. So it is grabbing the value of the item in position 0. And B is grabbing the value in position 2. Yes? All right? And notice the right-hand side is the array. So this here is the equivalent of doing this up here. Very good? Right? Now it doesn't look very like much right now, but as we use this in a loop, or we use this in an actual use case, we'll see how powerful this is. Okay. Also, if you want to swap things now, you can use this alternative syntax where you have BA equal AB, right, and they're swapped without having the temporary variable. Yes. Okay. All right. So that's arrays. Let's look at the equivalent for objects. Right, so here's an object, right? And so we have an object with A, B, C, D, E, right, with values, and it's a very common operation that, right, we just, maybe we have a long object name and a whole bunch of properties. We don't want to use it over and over and over and over, right, all throughout our code. So we copy it into a local variable, right? A gets temp A and C gets temp C. Yes, it's a very common operation. With the new syntax, you can do the following. You can use so the curly bracket on the right-hand side is constructing the object, right? It's telling what the properties are, what the values are. But the curly brackets on the left side of the equal sign is destructing the object, not destroying the object. It's not removing or deleting the object. It's grabbing the items from the object whose name, right, the property names match. See that? So careful. In the array is by position. What position am I in? Here, there are no positions. Right? This could have been C, comma A, or A, comma C. You get the same result. Right? It is by name, pattern matching the property names. Yes? Everybody good? This is declaring brand new variables. This is declaring brand new variables, and just like over here, we're declaring new variables A and C. Same thing here. We're declaring brand new variables whose values are taken from the source object by name. Everybody good? Right? Okay, so now let's try and start looking at this at some more use cases. Where it becomes powerful is when you start using this in combination with function calls. Right? Notice here you have this function, and you are receiving an argument here. In that argument, notice that I'm passing an object. See that? I'm passing an object that has two properties, two values. So internally, that this is an object. You can deconstruct you can retrieve the properties, maybe copy them to a local variable like we're doing here, right? And the other one, and then you can just do whatever you want. Okay, everybody good? Right? Now, using the new syntax, right? You can use the destruct syntax, right, in the parameter list. Right? So now, instead of now having to declare local variables, do the retrieving each individual property and copying to local, you can do all that in one single declaration. Right? So you do a curly bracket, and so what I'm doing, I'm destructing whatever I'm receiving. I'm expecting an object. I'm expecting that that object has properties, name and value, right? So I'm at the same time declaring variables name and value and initializing them with whatever object that you're passing me with the properties name and value. Like that, right? So obviously this is much more terse, right? You don't need to declare the intermediate variables. They are already declared in the as if they were parameters. See that? Right? So this is not so much more compact. You have to declare them anyways, right? Might as well do it all in one shot, right? So instead of using, so this one saves you having to do this multiple times, arc dot, arc dot, arc dot, arc dot, everywhere, right? You do that once with curly brackets and you're done. See that? Right? So that is so much more terse. This reminds me of C++ with a pointer signature. Right? You can either do arrow everywhere, or you can do a dereferencing at the argument level, right? Or at the ampersand. You do the ampersand and says, okay, now it's all referenced, right? You don't have to go and do all the arrows everywhere, right? Same thing here. You just do it at the parameter list and boom, right? You don't have to repeat that everywhere else. Yes. Okay, so now it could be that the actual property that you're being passed might not be a very convenient name, right? And you need to rename it to something else. You can rename it with an optional colon syntax, and you can rename it to give it something, some other name, right? Okay, you can also do the destructing with arrays, right? You can pass a function, an array, and you can have the square brackets destructing the values, and you can declare the variables right there in the parameter list. See that? But careful, here the values that you're getting here are getting the values from the original array in the order in which way they were declared. See that? So here the order matters, correct? In objects, the order, it doesn't matter. Right? Notice that here you have you can pass in name val, but it could the parameter list could be name comma val or val comma name, right? Also here you can skip, right, and only destruct the single property that you care about, right? All the others would be ignored, right? Only the ones that match by name will be destructed. All the others would be ignored. Yes. Whereas here in the array, you have to be more careful, right? Because they have a particular order. Yes? And you can't skip. Right? Again, following the goal of making the syntax of the language more compact, something very common that happens in the language is that when you're declaring an object and you have variables that you're combining them in properties of an object, it happens very commonly that the name of the property is the same as the name of the variable that you're storing in there. It's a very common thing that happens all over, over and over. So you would end up with x colon x or y colon y, right? It looks redundant, right? So the language allows you to have a shorthand version of that where it's just x comma y, right? So basically, it shortens everything by half. Okay. Again, very common. You'll see this all over the place. Right? So you need to be able to read that. It says, what is this? A curly bracket x y? What's that? Right? Yeah. So the labs have a couple of exercises for you to play around with for destructing objects, destructing arrays, and just displaying them. Retrieving the values from an array and then assigning them to a destructed declaration of constants, and then asking what the output is. In a quiz, typically a question might ask you, hey, here's a source object 1, here's a source object 2, spread it over this other object, and then destruct it, and then spread it again, and there are collisions. In the end, B is declared here, then B is destructed, then it's overwritten there, blah blah blah. In the end, it's asking, well, what is the value of B? Okay, so you have to go through the whole thing, seeing where things are overwritten. So again, practice it, yes, so you follow along and you understand what it does. Okay, then here there's also an exercise that asks you to play around with destructing functions, right? Where here you have, for instance, add 1, 2 using the normal syntax, right? Normal syntax where you're passing just individual parameters. But then here you have a version where you're not passing individual parameters, you're passing a single object, right? That has properties a comma b. So here you're passing a comma b, right, with values 4 and 2. And here we're destructing them, assigning local variables a comma b, and then responding with a minus b. Yes, right. So again, practice this. Do it with multiplication, with addition, with some logarithmic, some sine, right, some trigonometry. Just play around with some operations until you're sure you understood it. Okay. And so here, a note on the fact that we have been importing up to this point, right? Notice that in many places we've been importing. Notice that there has been cases where we are importing something, and sometimes we've been importing it just like this, right? Where you have the import the name from the file that we're importing. Yes, right? And sometimes our imports, if you might have noticed, sometimes our imports are inside of curly brackets. I don't know if you've noticed that, right? That sometimes we use curly brackets in our imports, sometimes we don't, right? And so let's talk about that. So when you do the imports, these curly brackets, those are destructing. That's a destructing syntax. Basically, what's happening is that when you import from a library or from a file, what you get back is an object, right? You have an object, curly brackets, and then all the items that are exported, right, from that file. Right? So here, we have a file, and we are exporting a whole bunch of stuff, right? We're exporting these 4 functions: add, subtract, multiply, and divide. Right? So we're exporting those 4 functions. So when we import, what we get is an object that has properties add, subtract, multiply, and divide. Yes? So here in this import, that object that you get from this import over here, we are locally destructing it so that locally we are assigning, we are declaring new variables here or constants that get the values from the object that is being exported. Yes? Right? So basically what, from a file, you can export a lot of things, right? You don't, up to this point, most of our examples have exported a single thing, right? Single function. Yes? Right? And in those cases, and most of our export have been default exports, something like this: export default and then the function name. Yes? In those cases, they can only, you can have as many exports as you want, and optionally you can make one particular export the most important, the one that you care, right? You get to choose which one is the most important export in this file. Yeah, and you get to choose which one. Now, if you make one of the export the default export, when you import it, you don't need to put it in parentheses, in curly brackets. It is the default export, right? You get the benefit of not having to you don't have to destruct it, right? It is the thing that gets exported. Yes. All the other ones, that are not default, which are all the other ones that are exported, right? Remember, only one default. All the other ones, if they are exported, they are lumped together in this object that you then need to destruct. Everybody good? Right? Okay. So yeah. So we've math is what we are exporting by default. And what are we exporting by default? We are exporting by default an object. See that? An object that contains what? Property add, whose value is add. Property subtract, whose value is subtract. Property multiply, whose value is multiply, and divide, whose value is divide. Remember, this is a shorthand for add colon add, subtract colon subtract, multiply colon multiply, and divide colon divide. Yes, using one of the the abbreviated syntax that we saw earlier, right? So math itself is an object. Right? This is an object. So you can call the function in different ways. You can call the same add function different ways. You can call it math.add, or you can call it just by add. See that? Right? So you can call into these functions in different ways, math or add. You can also do import the whole thing star and then assign it a local name, right? So from math, you can say, okay, well, grab everything, that the object that gets exported, the whole thing gets exported like a one big object, right? And then locally, you can give it a name, Mathematica. So now I can call add in different ways. I can call it as math.add, or just plain old add, or Mathematica.add, right? So there's different. And we'll see different syntax. We'll use it. Sometimes we'll use one. We'll use other. But I'm just introducing different syntax that you'll see, very very often as we go on. So yeah. So here's a couple of examples of calling the same add different ways. Just calling it add by itself, or math.add, or mathematica.add, and you get basically the same result. All right. Also in ES6, well, we introduced the imports and the exports, like that we've been using for the last couple of weeks, right? And exporting functions, exporting variables or constants, right? And using the destructor. So that was introduced also in version 6, right? Which we've seen several examples of that, right? Of importing and exporting different variables and functions. And also in ES6, we introduce classes, right? Where, very much what you would expect, having a constructor, having mutator functions in there, like setters and getters, and private and public members, right? Public and private members. Now, one of the things that the syntax is that any local properties are declared using this keyword, right? Correctly used, right? The correct meaning for this, right? And you can initialize those values by using this.id and assigning the value from the constructor. The constructor is the keyword that gets called when you call new and then a shape, and then you can pass it in. The constructor gets that, and you can initialize that, and then you can get you can declare any number of mutators that allow you to convert or mutate the values of the state variables. You get the super keyword, like you would expect in another language. There has to be the first line in the constructor, like very very similar to all prior other languages. Let's see. So here's just an example that you can also have inheritance, right? Like you would expect in object-oriented languages, where rectangle can inherit from shape, circle can inherit from shape, right? And you can call the super shape, right? Initialize those common properties and then override the ones that are just particular to your class. You also get mutators that so that instead of having to use set with or get with, it allows you to just declare the property, right, and then just use regular dot notation so that if it's on the left side, you're using the set, but if it's on the right side of the equal sign, you're using the get, right? And you're either reading or writing to the property, but it's calling these functions, set, get, okay? And you have static values, right, that don't change with each instance, right? It's the same value throughout multiple instances. You have base classes where you can override other functions from your parent, right? And where you call your parent's version, right? And then call yours. So for instance, here you have rectangles overriding the toString that converts it into a string representation, but it's calling its parent toString super.toString, right?